Welcome everyone, and thanks for showing interest in this topic. As introduced, my name is Kishore Sirivella. I work as a senior site reliability engineer or DevOps engineer at OpenTable Inc. So I don't know if you guys have heard about OpenTable. It's predominantly a US-based company trying to set its base in Europe. We do have some restaurants tied up with Berlin. So what our mission is to experience the world via dining. So we are a online restaurant table reservation company where we provide inventory management and guest center for different restaurants. So today my topic is monitoring apps and infrastructures using Python tools like Django and Celery. So before we get into the talk, I would like to ask a question to the audience. How many of you have kids? Oh, that's okay. I don't know why I have picked up that analogy. I'm not married and I'm single and I'm open to mingle, but I can't advertise myself or market myself because I'm being monitored by the PyConDE code of conduct. And at the same time, when I ask you questions that if you have kids, do you monitor them? I think so, most of you do. Or let me rephrase it to appease wider audience. Do you monitor your girlfriends or boyfriends' phones or personal lives? So the reason why I'm asking you is that we always monitor things, and at the same time we are being monitored by the society, governments and every stuff. So why do we do the monitoring? So monitoring is something that you do on your maybe your loved ones or whatever on things to make sure that it's performing as it is supposed to be. So you are making sure that it's on the right path, it's not deviating from the path that you intend to go, and at the same time to have an early warning before it's too damaged. Like people say, prevention is better than cure. So that's the reason we do monitoring. So let me come back to the analogy of parents monitoring kids and stuff. So when I write a code, I see it as my kid. So, and this kid is going to create billions of dollars revenue, and it's going to be a livelihood for many other customers, and at the same time it's reliability, and at the same time a reputation for your company. So it's very essential for us to monitor our own apps and infrastructure to make sure that it's crucial, it's on track, it's not deviating from what you want to, it's working as expected, and so that even if there are issues, we would be indicated by monitoring so that we can take action before further damage is being done to your applications. So that's all the talk is about. And I'm going to give the agenda is that we do have an existing platform set up using monitoring, how we are doing the monitoring, but there is a problem with it. So we try to solve that problem using Python tools like Django, Celery, keeping Sensu intact. So before I go into the Python tools, how we used them for monitoring, I want to give a short introduction to monitoring. That's what I was doing till now, and I'll give a short introduction about how the existing setup was at our organization and what are the tools that we are using for monitoring. So people who are familiar with DevOps or site reliability engineer, Puppet, Ansible, Chef, these are all the configuration management, and I want to give an introduction to this because Puppet plays a very major role in our existing monitoring setup. So Puppet is a configuration management tool where we get to set up the infrastructures, we get to code the infrastructures. It's a configuration management tool, like the Wikipedia definition says. It's for establishing and maintaining consistency of a product's performance, functional and physical attributes with its requirements, design and operational information through its life. It's blah blah blah. It's what Wikipedia gives it. So what it basically does is that, like, you want to make sure that your servers are having a consistent configuration so that it runs perfectly in production and there are no deviations from your testing environment that you have done it in your local machines or whatsoever. So it just basically makes sure that it's consistent across your organization. So for examples, it's like there are other alternatives for Puppet. Those are Ansible, Chef, SaltStack and stuff. So Puppet is a pull mechanism tool. I want to talk a bit more about here because that's where the problem of the existing setup comes in. So Puppet, when I say it's a pull mechanism tool, it's a client-server architecture. So Puppet has a server where you send all your manifests. Manifest is nothing but a set of code that's written to perform some installations of files that you want to see it on a server. So this is called a manifest, and server has it, and the clients basically have Puppet agent running on them, and they pull this manifest every 5 or 10 minutes as you like it. Like, you can set up the cron schedule for it, and the client basically pulls the manifest every 5 or 10 minutes from Puppet server and runs it on the agent or the clients, and your server would be configured to that configuration. So this is a sample code. I hope you guys see it. So I just will go through the Puppet code, how it's written. So the keywords exec, package, service, file, these are all the resources that Puppet provides. So let's go through the exec is a apt update. So the command we are running on this server is that you just apt get update, you're doing the apt get update, and I'm making sure that Apache 2 package is being installed. That's what ensure does. It's just making sure that the server has Apache 2 installed on it. So before installing, it's just making sure that apt update is being required or it's being done. So that's the same applies for MySQL Server, PHP 5, and the PHP file configuration. So Puppet, when it comes to Puppet code, Puppet follows its own code, like you see, unlike Ansible and stuff, where Ansible uses YML, which everyone is familiar with. So here, when it comes to Puppet code, there is a bit of learning curve. So Puppet basically will be dealt with most of site reliability engineers or DevOps engineers, and basically developers might not be aware of the Puppet code. But the thing is, developers are going to write checks for their applications, right? This monitoring checks that they want to perform on their applications to see if their application is working fine or not. So they have to write it in the Puppet, which is a painful thing for them. So I'm going to talk about Sensu Checks a bit more moving further. So Sensu is what the monitoring tool that we are using right now, and we are going to keep it intact without peeling it off, and we are just using Python tools upon the Sensu monitoring tool so that we can get the whole thing and remove the Puppet in the picture. So as per Sensu's definition, Sensu is a telemetry and service health checking solution for multi-cloud monitoring scale. Like I said, whatever the monitoring that I have mentioned in the earlier, that's what Sensu does. It runs some checks on the applications or on the socket or on the even some measurements that it collects, and it sends to Graphite and stuff, so you can be aware of how your application is being performed. So even Sensu has the client-server architecture. I'll go through the architecture diagram quickly. So it has a RabbitMQ message bus. So the server and client never communicate, they only communicate with the message bus. So server communicates to the data store, and the data store here is the Redis that we are using, and using data store makes us a stateless application. So basically the checks that are written and are managed via Puppet are stored in the Redis, and server talks to the Redis and get the checks and send it to the RabbitMQ, and clients subscribe to these checks if they want to run these checks. So when the client runs these checks, it sends the results back to the RabbitMQ message bus, and server basically grabs that results and put it in Redis. And API can leverage those results from data store, and you can build dashboards and everything out of the data that we have from the Redis data store. So this is a quick architecture diagram that we are following right now. So I have given you this info because I'm going to tell you what the problem is, or how we are doing it, and how we are leveraging Sensu server API to do the monitoring. Okay, so let's come to Sensu Checks. So this is what I was talking about, the checks. These are the crucial thing for monitoring your applications. So checks are nothing but the commands that are run on your clients or on your applications or even on your graphite data, so that we get to know idea of how it's performing. Like if there are more number of 500s that's coming out of your application, you would be triggered an alarm saying that, hey, there are like more than 500 or 1500s your application is throwing on. So there is some really problem with your application, so you have to get onto your application and look at what's happening. So when a Sensu check or commands are executed, it basically the output would be std out and std error, and the output, basically the exit status code will have 0, 1, 2 or unknown. 0 means which is the check is working fine, you are fine with the check, the application or whatever you are monitoring is working as expected, there are no anomalies, everything is going good. And 1 indicates warning, which means there is a problem, you might need to attend or you may not. It depends on you, and you know your application better. So, and this warning can be set by you. It's not something that Sensu does. The warning threshold and critical threshold are set by you when you are writing the check definition. So you are aware of how much it has to be and how much it should not be. So 2 indicates critical, which is a critical thing for your application. You have to get onto the laptop and look at what your application problem is and try to fix it. And other than 0, 1, 2, there is an unknown status, which is there might be a problem running in the check, or there might be a connection issue, whatever it could be, or even if you want, you can make it as a customized message for that status. So this is a brief introduction of checks, and I want to talk a bit about Nagios plugin. So Nagios is an alternative monitoring tool for Sensu, but fortunately the plugins that are written in Nagios are compatible with Sensu. So there are lots of plugins that's already written, like there are checking an HTTP check, or be it checks that are working on your graphite data, or lots of mathematical calculation plugins. Everything are available in Nagios already. So we are not trying to reinvent the wheel. We are just trying to use whatever is applicable and make sure that application is running. So here is a sample check HTTP Nagios plugin. This is how a check basically looks like. So here, what the check is doing is that so like I said, we can set up the warnings and criticals. These are set by the developers itself. So here I am setting the warning threshold as 5, -c is the critical threshold is 10, and you are asking the check to connect to host open table via SSL, which is 443 port, and if it returns a status code within 5 seconds, your application is running fine, your website is running fine. So if it goes more than 5 seconds, it takes more than 5 seconds to give a response code, then your website is responding slow. So you have to get on to see why it's taking 10, and critical if it's more than 10 seconds. So what are Sensu events? Once these checks are run, we get outputs which have the status code 0, 1, 2. So depending on the output, events would be generated. Basically, when there is a warning or a critical or an unknown status, Sensu creates an event. So when an event is created, there are a concept called handlers. So you can write your own handlers, or Sensu has a default handler which handles these events. So what basically handlers does is that whenever there is an event triggered, based on the handler that you have written, it performs that action. So say suppose you can remediate an automated you can make an automated action, like say suppose if a disk is full and you know that these are the files which always fills up your disk, and you get an alert saying that hey, your disk is full, like out of 100 GB your disk is already full up to 98 GB, and you know the cause already. So you can write an automated action saying that just clean up the disk, and Sensu handler, make it as an handler, and Sensu, whenever there is a alert triggered based on this check, it's gonna automatically delete the files from that, so that the check will be resolved. Yeah, so that's mostly about handlers. This is a key part for our application because this is where we are going to use Sensu handlers using Celery and Django to run the whole monitoring system. So this is the existing setup. We maintain all the checks in Puppet like most of the tech industry is doing. We basically have all our checks in configuration management so that we know that every server gets these checks to be run, like infrastructure checks, like what's the CPU of a system going on, what's the memory of the system, how is it spiking up. So these are all being managed by Puppet, and there is a Puppet learning curve. Like I said, the code, Puppet has its own language. So there is a slight learning curve for developers to learn it and write their own checks. And Puppet code is maintained by ops guys or site reliability or DevOps engineers guys. So we review the code, and basically developers has to wait for our review and let it merge into production. So even the prod merges take some days, hours of time, and sometimes even days of time. That's not the ideal case every time. Like if there is a holiday season where we basically dine 2 million diners on a single day, and if a new service is added into the production and they want to write checks, which is a painful aspect for us. And at the same time, in the Puppet code, like I said, Puppet has its own language. In older versions, at least till Puppet 3, which we were using at that time, doesn't have any iteration function. So whenever we need to write a similar kind of code, we used to write the whole code again. There is no reusability done, and which was a painful thing. We need to literally write the same code again and again for the same checks. And at the same time, Sensu does give us a dashboard of number of checks and the results, which is called Chiva, which is not that great to view and stuff. So that's another painful thing. So what did we do to resolve this problem, and how did Python play a major role for solving this, or at least Python tools like Django and Celery did? So we came up with a solution that Puppet should be removed, at least for managing and maintaining these checks. It has to be moved to a newer system so that it can be added quickly by the developers if they want. And who doesn't love UI? So we are going to make it as a UI one. And at the same time, we are going to give them role-based access control. So every team can check their own checks. They can delete, edit and stuff. They need not wait for the ops guys or SREs to review their code and stuff. At the same time, there would be no minimal learning curve for engineers, because it's a UI and it's self-explanatory. There are all informations provided. You need not learn Puppet code. So we are eliminating that learning curve. And you can create multiple checks at one go. It's basically UI. So as soon as you create the check, you get an option saying that clone the check, and it clones the check with a different name. It's as simple as that. I can't show you the UI or demo due to security reasons, and at the same time restriction of the time, but I can give you an explanation like how it's going to be. So this is another big aspect that we try to solve, which is testing the check result instantly, because like I said, Puppet has its own language, and in order to test those checks that are written by the developers, if they are working fine or not, they have to set up Puppet in their local machine in Vagrant and run these checks to see if it's working or fine, and no one does that. Literally, we tested our own checks in production, which is a very bad way to do so. So what we did in this solution to the problem is that we have run the checks whenever they created. We have run those checks in the backend, and I've shown them output, and when they're satisfied with the output, it's being created and stored in the database. That's how we know it's being tested way before it's going into production. And we also created APIs for creation, reading, updating and deleting these checks. And we do have bots in our Slack messaging. Like I've written a bot called Airbot, which basically leverages these APIs even to create and stuff. So you can automate these checks and everything. So this is the solution we tried for solving the problem that we had previously. So how did we solve this? What is the tech stack we used to solve this? So we didn't remove the Sensu. We kept the Sensu intact, because Sensu has this Nagios plugins, which is working very fine. We don't want to interfere with that. At the same time, we don't want to rewrite all those plugins again for ourselves. So we basically kept Sensu as it is. We just removed the functionality of running checks from Sensu, and we gave that function to Celery. So Celery is a distributed management system. It's an asynchronous task or job queue running system which runs tasks for you. So what we did is that we removed that function of running checks from Sensu, like probe nodes and stuff, and we have given it to Celery and let Celery run for itself. So Sensu is being only used to handle the results of it and to use the existing check plugins that we are already using. And here comes the main thing, which is Django. We used Django for the web application, which is a UI for check management and storing the checks everywhere in the database, and for creating visualized dashboards, everything. So Django played a very key role for us, and it was a learning curve even for our team, since we never worked with Django, and we were very happy to do that. So this is a view of how our UI looks like. This is the old one. This is not how it looks right now. Like I said, I can't show it to you. So this is something old one. So you get like home, checks, services, team. So once you log in, you get to see your own checks, what services you own, what teams you are in, and what's their performance, how it looks. So when it comes to checks, there are multiple different types of checks. It's not like every check does the same functionality, right? So there are like three major types of checks that we were doing. One is HTTP or HTTPS checks. Basically, the example that I've gave, it just pings a host like www.opentable.com to see if it's up and running, if it's responding to the ping. And Mesos is Apache Mesos. If you know, it's an orchestration tool which we are using for running all our tasks in productions. So we wrote checks to check if the services are running fine in Mesos, if they are responding fine in Mesos. And Graphite checks are the ones, like I said, Sensu can have this plugins which basically collects all the measurements, collects all the data and sends it to Graphite. And once you have this data in Graphite, you can run checks on this data. So basically, if say in our scenario, we do have a reservation check, basically, like we know that every weekend we do get some 100,000 reservations on a weekend. And if we can write a check on that to see that if it's hitting 100,000, if it's not going there, is there a problem with the application that we are dealing with? Is there a problem with the booking flow that's happening? So basically you can run checks on the Graphite. So the best example is that your application sometimes give 500s and stuff. It could be because of multiple reasons, but like say 1 in 10,500 is not a big thing. But if there is like 500 in 1,000 number of 500s, then it's a painful thing. So you can run Graphite checks on that to see how many 500s are being generated, and if it's crossing a threshold, you should be warned for it. So that's the types of checks. And so this is the ability to test and check before committing the check into production. That's what we try to solve using Django and stuff. You can ability to clone, check and edit, and use bots by leveraging APIs. So here is another big chunk of performance by Celery with respect to running the checks. So like I already mentioned, Celery is an asynchronous task or queue distributed system. So it's used for running these checks as tasks. And what happened is that, like I said, we have different types of checks like HTTP, Mesos and Graphite checks. So what we did is we created different queues. One is for HTTP, one is for Mesos, and one is for Graphite queue. So what happens is that Celery has a concept called Celery Beat, which can be used to schedule these tasks. Like it could be a cron tab schedule or any type of schedule if you want. It could be a customizable schedule, everything. So what this Beat configuration does is that, say suppose I want to run all the HTTP checks every 1 minute to see if my website is up and running and it's responding properly. So Celery, I have configured that it in Celery beat, and it's gonna run the task, and the beat will be looking upon these queues. So as I mentioned that I want to run these HTTP checks every 1 minute. So all the HTTP checks are going to be into the HTTP queue, and beat is going to run the HTTP queue every 1 minute as per the schedule. And Celery workers run these tasks based on this beat schedule. So Celery has its own cluster where it has workers running for this task to run, and it can be scalable easily. So I'll give an idea of how Celery beat schedule looks like. So this is the beat schedule that I was talking about. So if I say HTTP check is my beat schedule, it's a schedule 1, and the task is written in task.py in Django, so which is my function, which is master HTTP, which has all the HTTP checks in our organization. So I have given a schedule like run every 1 minute this master underscore HTTP function, which basically collects all HTTP checks in the database and run it every 1 minute once. The same applicable for Mesos check. Yeah. So Celery Flower, and this is a picture from internet, it's not from our application. So Flower is a very good tool that Celery provides to again monitor your own Celery cluster. So there's lots of monitoring going on. So you are using Celery for monitoring, and then your Celery cluster is being monitored by a tool called Flower, and it gives very good details like what's the worker doing. So the name celery1.py.local, these are all the workers which are scalable, and how many tasks are being running, how many completed tasks, what's the concurrency of it, and what are the queues running on those tasks and everything. So Sensu Results API. So like I said, we have removed Puppet from our existing setup. We have introduced Django, we have introduced Celery, but we kept Sensu intact, like I was mentioning. But like I also mentioned, we removed the function of running checks from Sensu, and we are leveraging only Sensu Results API. So what happens here is that when Celery runs these checks, it's going to create an output for you. And what we did is we send this output to Sensu Results API, so that Sensu has all these handlers, and based on these results, events are created, and Sensu is going to deal with handling these events based on whatever handler it is being assigned to. So we are not going to remove that functionality because it's working fine, and there are existing plugins, and it's very good. We don't want to interfere in that. So Celery runs the task, sends the output to Sensu API, and Sensu API, depending on the output, creates events, and if there are events, it's going to be handled, like paging you or sending an email or pinging you in Slack saying that your check is being failed, you have to get on and see what's happening. So this is a sample code that we have written to send output. So if you see the command, it's a Mesos check that we are trying to run. So Discovery is a service that we developed in-house to know which services are up and running, so that they can announce themselves each other saying that, hey, if there are like A and B services dependent on it, A service will announce I am up and running, and B service also announce I am up and running, so they can communicate each other. So that's a in-house application that we have developed, which is called Discovery, and FNS is name and the endpoint that you are looking for, the timeout that you are looking for, and what is the warn threshold, critical threshold and stuff. And once it has been run, we are using normal subprocess command, which we get the output out of it, and we are sending this output to the Sensu params. What is the name of the check, the output, the status, the handlers that the event that check was assigned to. If there is an event based on the output of that check, how should it Sensu handle it, and what's the team that it has to send info on, or does it need to be paged to that team? If the check is very critical, do you need to inform the team? Then you make sure it's true, then notify email and stuff. And here we are sending it to URL request.post. So how did we deploy this? We deployed it in Docker containers because everyone uses containers and it's very easy to scale and easy to monitor and stuff. So we opted for 2 different Docker files, one for web app, that is Django based one, and another for Celery. The reason we did that is that if web app goes down, we don't want checks not to be running. Checks should be running always, because that's very critical for our organization and for our application, because that's how you will be informed what's wrong with the system. So we separated 2 separately in the Docker files. So the Docker file with Celery will be having the Celery workers running based on the beat schedule that I have mentioned previously, and web app would be running for UI, so that people can add checks and delete or do whatever, or visualize the checks based on the results. And it's running in Apache Mesos environment. Yeah, that's pretty much about it. That's how we solved using Django and Celery, keeping Sensu intact, and that's how we monitor our applications and infra. Thank you, guys.
So a quick note from my side for those who popped in during the talk. Apologies that I started the talk ahead of schedule. I realized while Hari was already talking. Sorry for that, but we do have more time for questions now. So there is one.
Hi, thank you for talk. My question is, have you considered Prometheus for solving this issue?
We did, but Prometheus is more of, the way we pursue Prometheus is more of an alternative to Graphite, more into visualizing stuff and data. But there are some checks, like I was mentioning, like Apache Mesos checks or be it HTTP checks and all. This has to be run and maintained somewhere. We thought it's better to have it a separate way and not to merge with the data stuff that we are having already. And we did even face some bottlenecks with Prometheus, to be honest. But I haven't dealt with it personally, so I can't comment more on it. But we did see some bottlenecks with Prometheus. Thank you.
Yeah, so I have no idea what your company does actually, because I missed the start of the talk. But it seems to me that like you guys invested a lot of time in creating this, like you created a whole monitoring tool and the UI and everything else. Wouldn't it have been easier to just go with a solution that already exists? Like just learn it and implement it and be done?
Yeah. So are you talking about any paid tools?
Possibly paid, possibly free.
Yeah, so we are more into open source. We always wanted to contribute. It's obviously we can save money too, and at the same time we need not depend on someone else. So that's our main goal. We have to solve our own issues. And like I said, we did have an existing setup like Sensu and Puppet. It's widely used. If you see their repo, like thousands of organizations using it, and it's the same format. But like I said, there were lots of pain points with that, like developers have to wait for it, and there is a learning curve for it. There are no iterations with the Puppet version that we are running, so it was a very painful thing. It was going well for 2 to 3 years, and then everyone started shouting at organization, no, we can't do this. Like I said, during holiday times like Christmas or New Year's, our site goes up like anything. Everyone wants to book reservations at a restaurant, and if there is a new service that we want to add it in a production, just adding checks will take lots of time. And because it's a holiday time, people would be on leave, there would be no one to review the code, there are lots of bottlenecks. So we thought, let's do it a new one, because it's going to stay forever. Monitoring is not going anywhere, so we will be monitoring as long as there are products in the production environment. So we thought of going the whole way. Yeah,
thank you.
You're welcome.
I have a question. How does your monitoring system support calculating how long your uptime of the system is? So if you are 90% or 99 or 99.9?
So we do run all these checks and send this data to Graphite. Like I said, say suppose check HTTP and stuff. These run checks, and based on these outputs are sent to the Graphite, and you can get the data out of Graphite. So we are basically calculating that in Graphite and Grafana tools.
Okay, thank you. Other question? I have yet another one.
Sure.
If I were to monitor a web application that is several orders of magnitude simpler than yours, like where I don't depend on the thing being 99.99% up at Christmas, for instance, what would you recommend to a beginner? Where would you start if I were to build my first monitoring system?
That's great. So that's a good question, actually. So I would say, like, since we are used to Sensu, even Nagios is good. Nagios is way easy to install and compared to Sensu. And even Sensu is coming up with great features in their newest product, which is Sensu Go. So I would say, as a beginner into monitoring, I would say Nagios is the best way to go, because there are lots of plugins already available and it's easy to install, and you can run it on your local machine very easily without high consumption of resources and stuff. Yeah, Nagios would be your best.
Okay. If there's no more questions, then let's thank the speaker again.